Hello and welcome to Season 2, Episode 9 of LogiCast. I'm Carl Robinson, CEO and co-founder of Logicata, and I'm on location today. More about that in a short while. I'm joined, as always, by my colleague, John Goodall. How are you doing today, John?
I'm fine. I'm very well, thank you.
Oh, my word. What are you on today, John?
Oh, I'm just high on life and helium from children's party balloons. Note to the listener, do not do that. It's bad for your health. Still fun.
Never fails to amuse, though. Never fails to amuse. Still legal, as far as I'm aware, to do that. So, we're not encouraging our listeners to break the law. Never fails to make me laugh. Anyway, very childish, the pair of us. So... Anyway, as I mentioned, I'm actually on location today for the first time ever. I'm doing LogiCast from a location that is not my shed. And I know it looks very much like I'm in a passport photo booth, but I'm actually in a very compact hotel room. This was the best view for anyone who's watching the podcast, not just listening to it. This was the only view I could have in the room without a mirror behind me, highlighting the bald spot on the back of my head, which regular viewers will have no idea that I actually have because they only ever see the front of my head. So let's keep the back of my head a mystery for LogiCast listeners and viewers for the time being. So anyway, we're not here to clown around with helium and talk about my hotel room. LogiCast, if you are a regular listener, you will know, is our weekly AWS news podcast. Once a week, I curate a list of AWS news, which I share via my weekly AWS Roundup newsletter. And then John and I pick a subset of the articles that are in the newsletter that we would like to talk about in more detail. So we've got a number of those articles for you again this week. So without further ado, let's carry on with the matter at hand. And our first article this week is introducing AWS Lambda Powertools for .NET. So Lambda Powertools for .NET has recently gone into general availability. And I chose this article on purpose because I know it's going to be a real love-hate thing for you, John, because you love Lambda and you absolutely despise .NET. So you're going to have to talk about both of them, I'm afraid, although perhaps you can steer the article more towards the Powertools and less towards the .NET. So I did have a quick scan of the article earlier, and I can see that there was previously Powertools for Python and Java, so I suspect you're probably more well versed in using those. Explain to us, John, a little bit about Lambda Powertools, and please talk a little bit about .NET because I know how much you love it.
Yeah, very Marmite article. This is a very British reference. I love talking about Lambda. I mean, I'm a community builder in the serverless category, so I have to talk about Lambda. I have to. It's kind of like they'll beat me if I don't. So there we are.
Do we have to mention that on every podcast now?
I think we do. Yes.
Okay. I think I might have an opportunity to mention my status a little bit later on. So mental note.
Got to get it in every episode now. It's like it could massive tangent already, but it's like those Hollywood interviews on the red carpet. Try and get words into every response. Got to try and get community builder into every episode.
Well, you've now done that twice, so
hey, there
we almost need a little a sound effect ding for each time you mention it.
I'm very good at this. Powertools for Lambdas generally, it's not available for every supported runtime, but it's available for current standing Python, Java, TypeScript, and now .NET. What they do, it describes it in the article with the .NET lens on it, but fundamentally it's a suite of tools that help you do things that you would do quite a lot. I've used the Python Powertools fairly extensively. I'm now writing a large number of Lambdas in TypeScript, so I will be poking around with the Powertools for TypeScript as well. That's more in the logging space, and it's not as useful, but it's still there. But it's a suite of tools that help you do things that you would otherwise have to write large quantities of code for. The example I like to use in Python land is if you want to get something from, say, SSM or from Dynamo, it turns it into a one-liner rather than you have to initialize the SDK and then you have to connect to the table or connect to the item and then issue the command and then deal with the response and get the object in the right format. It turns about 8-9 lines of code into a one-liner, which is just enormously useful, especially if you're doing it a lot. Yeah. So that's why I like them. That's what they're useful for. The ones for .NET do similar sorts of things. Again, logging. So it's structured logging. It's here's how we think you should do logs. TypeScript ones do that too, which is useful because Lambdas can be incredibly verbose or very, very log limited, depending on the developer. So by having a structured way of saying, here's how you should do logging, you can do, I'm not a .NET dev, but you could do log.debug for debug statements, log.info for things that you want to see on everything, and so on. And then you set the log level at the environment variable level to say, in development, give me all the logs in creation. In production, give me only informational and error messages to keep my log levels down. Otherwise, it just gets too messy. Yeah. So that's very useful. That's incredibly useful. Tracing, another good one. So for those that are unfamiliar, distributed tracing through X-Ray is an incredibly powerful thing you can do with your serverless packages to give you more insight into what could be quite an opaque system. Because say you have this Lambda and it's running and it's talking off to another set of systems, it's talking off to another set of APIs, talking off to another AWS service, and so on. You can kind of lose sight of where your requests are going, where your data is flowing, and where the holdups and the bottlenecks in the system are. X-Ray solves for that because it's giving you traces, it's giving you data on kind of every single external call that you're making. So my call out to Dynamo took 5 seconds. My call off to this external API took not 5 seconds, 5 milliseconds. My call off to this other API took 10 milliseconds. My call off to a database took 100 milliseconds. Oh, there's my bottleneck. Okay, now we can work to improve that. So that's what that's good for. And again, it provides a nice, easy way of instrumenting that. Because again, in Python, instrumenting is just like a decorator on the handler, but it's a lot more complicated in .NET.
Your API call may well have taken 5 minutes, and if it did, I'm certain you would want to know about that. So,
oh well, yes, indeed.
Hence having the observability in place.
Absolutely, because it's one of those. My function took this long, and I have no idea where all that time has gone. Is it compute? Is it something I can tune the Lambda for? Is it something that I need to work around? Is it so you need the tracing realistically? And then if you've not used it, X-ray tracing gives you this really lovely graph as well of kind of where everything's going to get the nodes and the arrows between them and all the milliseconds and all the rest of it. Then it puts on some metrics, which again are useful. Things like, where it's coming from, where the requests are coming from, where they're going to, and all that sort of thing. And basically what this is doing is this is just providing a nice, simple way-ish of making your life easier when it comes to writing .NET Lambdas. Powertools exist, as I say, for Python, Java, TypeScript, and now .NET. And the offerings in them are a little bit different depending on the language and so on, because they just are. Because, like I say, things like X-ray tracing with Python is fairly trivial because it's a one-line decorator per Lambda. You don't need to worry about it. So they don't tend to include that kind of thing. But it's definitely worth a look for, as I say, those 4 languages if you are working in them.
Cool. Thank you for that. And you didn't have to say too much about .NET, so you managed to swerve around that stick on the serverless topic quite nicely. But from serverless, we're now going to segue rather neatly into servers, which is an area that we don't normally stray into because we tend to be more serverless, particularly as you are a community builder in the serverless category. But we are going to talk about servers.
We're going to have to put a counter on screen or something, aren't we?
So we're going to talk about servers, but we're going to talk about EC2 instances, of course. We're not going to talk about physical servers or any other type of virtual servers because this is an AWS podcast. So we're going to talk about EC2 instances. Before we do, I did mention that I'm on location this week. This is a great test for our tech stack for when we want to get other AWS community builders on to our podcast as guests. I'm currently sitting in a Yotel room in downtown Boston, well, in the Boston Seaport area. So I'm here for a few days visiting clients, which is nice. So a proper international edition of the LogiCast. It's not our first remote recording because I think you did one in a different shed.
I did one in Cornwall.
But it is our first international recording, even though it's still only the 2 of us on the podcast. But we are in different countries. Isn't the internet wonderful? So
speaking of the internet,
back to servers. So this is really a bit of a 101 article on the Droidmen site. We've spoken about a couple of their articles before, but it's real basic stuff around EC2. But sometimes it's good to go back to basics because often because things are so basic, we can mess them up because we haven't done the basics right. So this article goes on to talk about how best to protect your EC2 instances. So tell us, John, what should we be doing in order to protect our EC2 instances? And we can go through what the article says. And if you've got any other tips that the article has missed, feel free to drop those in as well.
Aren't you the operations community builder? You should be talking about operating things.
John, don't go too soon. Don't go too soon. That's
Oh,
two
have I stolen
articles
your
time.
thunder?
2 articles time. I'm going to get my
Okay.
community builder plug-in.
I apologise to anyone with the misfortune of listening to this. We will improve, I promise. Right, protecting EC2 instances. So the first thing in the article is define and secure your VPC. It's really easy to screw this up. AWS is aware that it's really easy to screw this up, so they've kind of made this a lot easier with like nice graphics and so on. So we're not going to talk about that at great length, but the point is by putting things in a VPC, you basically start using security groups and network access control lists, NACLs. Functionally, they work like firewalls, so you're only letting the ports in and out that are relevant. So it's things like making sure that you don't have SSH or RDP access accessible to the internet. Only have it accessible to known good IP addresses, or set up an AWS client VPN or something of that nature, so that you're not exposing everything to the internet.
Can I just say quickly there, whenever you say knackles, it always sounds a bit like an obscenity. I always find it a bit like an obscenity, the word knackles. But anyway,
it's a lot easier to say than network access control lists.
Yeah.
I mean, you could call them network ACLs if that makes you feel better.
No, I'm quite happy with the word knackles. I just do think it sounds a bit like an obscenity, a mild obscenity.
So that's the first one, right? Basically, it's in old world, it's firewalls, but it's just making sure that you've limited where traffic can come from to the routes that you expect it to come through. And this is where you see things like bastion servers, or jump boxes as they're sometimes called, which are more open than others, but are then more locked down. Yeah. The next thing in the article is talking about identity and access management. So this is IAM. This is the perennial IAM, which is always awkward and difficult for people to understand if you've not worked with it before. But again, what it works on is the principle of least privilege, so that users have the minimum amount of access that they need to do their job, no more than that, possibly less than that if you can get away with it. And again, it doesn't talk about it here, but it's, don't use the root user, set up individual accounts, don't share them, all that kind of thing, which again is good. It then says defining your security groups, and I kind of touched on that in the VPC piece because they sort of live in the same area. But basically, it's the firewall piece. It's just making sure that only traffic that you have allowed to flow from one location to another is flowing from those locations. And I would also recommend turning on things like VPC flow logs so you can validate that.
Although they can get quite expensive, as I understand, VPC
flow logs can, yes, in a very busy environment, yes, because you pay
if you've got a lot of flow to log. Yeah.
God. That's
it wasn't meant to be funny.
I'm terribly sorry again to anyone that's not British and doesn't quite get our obsession with toilet humour. Logs to flow. There we go. Right. Be vigilant against malware. So yeah, this is a fun one. Everyone should be aware of what it is. AV and malware and stuff is something that generally plagues desktop PC users, less so than it used to, but it's kind of an ever-present problem and threat. And it doesn't change in the cloud. It's making sure you've got your endpoint protection set up and making sure that you've got your security patches installed and kind of all that sort of thing that your sysadmin's usually whinging at you about.
Yeah, we use Sophos for that. Other endpoint protection is available, but we partner with Sophos and recommend that to our clients should they require endpoint protection in their EC2 instances.
Speaking again of EC2 instances, backups are always good, because with the best will in the world, someone will do something silly, someone will have broken in or done something accidental and deleted something. So make sure you're backing everything up. is always worth doing. That's less about protection and more about remediation, but making sure you do that and test it and so on, because a backup is only as good as the last restore, right? If you don't know that they restore, then they're no good to you. So validating that your restores and things work as well. I've never seen an EBS or an AMI backup not restore, but I have seen them not include what you thought was on them, because that's kind of always what the problem ends up being.
Have you seen EBS data loss requiring restore from backup?
No, admittedly. Well, not system-induced loss. I've seen people delete things. That's realistically what you're protecting against there. I've seen people delete things and go, "Blah!" So then you have to restore the snapshot and bring up a drive, and then, oh, look, there's your file for you, sir. And then the last thing in this is monitor using CloudWatch. So yeah, again, just generally good advice. Make sure you're monitoring things using CloudWatch, Datadog, New Relic, whatever. Pick a tool, install the agents, monitor your instances, right? Because you want to know that things are happening on your boxes. And they say CloudWatch here because it's all within the Amazon ecosystem, but other tools are available. But again, yeah, definitely worth doing.
Yeah, I don't know if it's just me being paranoid or belt and braces, but I always personally prefer to monitor Amazon resources with something that is not Amazon, even if that thing is probably in Amazon anyway. But at least it's outside the Amazon ecosystem. That gives me a bit more of a comfort factor to be monitoring what I've got in Amazon with something that's outside of Amazon. But you don't have to.
Yeah,
they provide you with all the tools, so you don't have to.
It's an interesting one because external tools are usually more expensive than the Amazon provided tools. So if you look at something like Datadog, they charge you per host to monitor, right? And it's not a small amount of money when you get above a handful of hosts. CloudWatch, you don't pay per host, you pay per metric. Each individual metric is relatively inexpensive, but once you're looking at, say, several hundred metrics, then the cost can start creeping up. So it's very much not an apples to apples comparison from that kind of lens. And there is one more thing I wanted to touch on before we moved on. It is in the malware section, but it's only really skimmed over. It's talking about instance hardening. So that is absolutely something that, particularly for Bastion servers, you need to be paying very close attention to. Because for those that are unfamiliar, a Bastion server, sometimes called a jump box, is a server that is more web accessible than the rest of your architecture, the rest of your infrastructure, so therefore needs to be more directly defended. So things like MFA for logging into your Bastion server, that kind of thing.
Yeah, and that's something you can do yourself if you really want to. But as with many things in AWS, it's already been done many, many times by other people. So you can find hardened EC2 instance AMIs in the AWS marketplace, some of which free of charge. We have one on our marketplace seller site, which is free of charge for Ubuntu Linux, I think it is.
Yes.
But you'll find lots that have been hardened against various different standards like the CIS benchmarks and so on and so forth. So if you want to start from a known good point, then marketplace would be a good place to go and look. Moving on from servers, back into our more comfortable land of serverless, but now we're talking serverless databases. Yeah, I think you could class it as a PaaS with a serverless option. So
yeah, okay.
you're not going to manage the servers for Aurora.
No, I'll give you that.
So regardless of whether you go instance-based or serverless. So anyway, this article is about improving application availability on Amazon Aurora. So obviously Aurora is Amazon's internet scale database built to take on the likes of Oracle in terms of performance and scalability, but at a much lower price point. So tell us, John, about this article about improving application performance on Amazon Aurora, because I think there are some things that you need to be aware of if you are going to take the Aurora option.
Well, because Aurora handles its own resiliency and availability for you, your application needs to know that these things can happen, right? In the old-fashioned world, if your DB server went down, it was just down. It wasn't magically going to just appear on another endpoint. Or if you were doing maintenance, it wouldn't, change hardware under the covers and have a different IP address under the DNS without you knowing about it. But with these fully managed services, that absolutely can happen. And certain tools and operating systems are very guilty of caching the IP addresses under those DNS endpoints, not telling you it's done it, and then magically not resolving after some fairly minor maintenance has happened. I mean, Windows does this for the whole operating system, which is just infuriating. Nginx does this. I've seen Varnish do this. Linux as an OS doesn't do it, but lots of things you install into Linux do this. So it's just like, okay, very irritating. So basically what you need to be aware of is the fact that your DNS could change under the covers, right? So you need to be making sure that the time to live on any DNS records are fairly low. I think the article is saying here, yeah, it's important for client applications to recognize the change as quickly as possible. Aurora endpoints use a 5-second time to live TTL setting. Yeah, which means that if it caches it, it will only cache it for 5 seconds, which is generally considered to be a reasonable balance between not having a fairly busy application constantly spamming the DNS with requests, but equally it will pick up changes relatively quickly. So that's very important. So there's that. The next thing to take account of with this generally, Aurora RDS does this as well to an extent, is if you've got reader endpoints and writer endpoints, it's making sure that your application is configured to do reads from the reader endpoint, not try and read everything from the writer endpoint and not use the read endpoint. Yes, you can read from the write endpoint, but the idea is that if you're doing read only, you read from the read endpoint because it's actually running from different kit. So if the writer endpoint has an issue, has maintenance, whatever, your reads don't have to be impacted. So that's the next thing to be aware of. Then the only other thing in there, again, is talking about DNS. Again, it's never DNS. It's always DNS. This is about propagation delays. So your TTL might be very low, but it might take a little while for things to kind of fan out across a fairly large distributed system. And again, the way of doing that is just making sure that your TTLs are nice and low and that your DNS is queried regularly so that propagation is kept to a minimum.
I was half listening to you there, John, and the other side of my brain was wondering if there'll ever be a James Bond movie called Time to Live. Well, has it been one already? I don't know. And certainly there's one called Time to Die.
No, it's Time to Die.
Well, close enough. So every time you said Time to Live, I was thinking, yeah, it could be a Bond movie. Random, I know. I apologise.
And then the only other thing that the article does talk about to just drag this back on topic is your application could, in theory, query the Aurora endpoints, not the data endpoints, but the service endpoints, to sort of see if there's anything happening that you need to be aware of, if anything's happening, and you can kind of preempt a switch. So you don't have this 5-second outage that magically resolves itself. You can see in a couple of minutes' time, oh, okay, and then you just start really quickly refreshing and that kind of thing.
Cool. So some architectural considerations for getting the most out of Aurora. Let's move on now to my opportunity to mention that I am an AWS community builder in the cloud operations category. And this next article,
what is that category?
Cloud operations.
Yeah, but like, what is it for? Like, serverless is for talking about serverless. What's operations? We all operate the cloud.
Well, some people operate better than others, and you can do serverless development without really paying a great deal of attention to how it's going to operate in the cloud, as we have identified on other episodes. But I think it's just where they put everyone who, like me, hasn't got a deep specialism in data. Serverless or any other particular cloud niche, but no, operations is things like monitoring, observability. It includes migration, so it includes there used to be a separate category for migration, but it now falls under the operations category. So it's getting to the cloud and running in the cloud. And this next article on TechTarget is about cloud incident response. So it's not specifically to do with AWS. It's a more generic article around cloud incident response. But obviously, from an operations perspective, incident response is hugely important. This article has a bit of a security slant around the incident, as you might expect, because it was written by Dave Shackleford of Voodoo Security, but it applies equally to other non-security related incidents, such as general failures, performance issues, and so on and so forth. So first of all, it goes on to ask the question, what is cloud incident response? So what's your view, John, and what is cloud incident response? And how does it differ from traditional incident response?
I think that's the key thing. It's not that different from traditional incident response. It's just there's a few other things you need to be aware of and a few things you don't necessarily need to be aware of. So things like your incident response plan doesn't have to particularly worry about physical attacks because you have no access nor interest in the physical kit, right? So you kind of can just take that and throw it away. You don't have to worry about it. But on the other hand, because of the shared responsibility model, and it talks about this here, is you are responsible for everything you do in the cloud, right? So if you've stuffed up a piece of configuration, AWS are not going to take the fall for it. You did it, not them. But generally, the framework is kind of fairly similar to anything I've worked with before. It talks about the 4 key phases, right? I tend to view them as more pillars than phases, but there we are. It's prep and follow-on review. So it's making sure that you've got everything kind of set up ahead of time and making sure that you're looking for the right things and the staff are trained and your plans are written and all the rest of it. Detection and analysis, which is talking around your SIEM solutions. It's talking around your monitoring and your observability and all that kind of thing. Containment, eradication, and recovery. That's a good one, that. Eradication. Which is, you an incident has happened. You didn't stop it from happening. It has happened. Stop it from getting worse. Fix it. Bring the service back up. And then the post-mortem, which it's an interesting term. I've seen some noise in the SRE community around not liking that because it all sounds a little bit dire, because a post-mortem is what you do on someone after they have shuffled off this mortal coil. And obviously there's no recovering from that. So why would you do a post-mortem after it's the wrong word. It's more like a post-incident review, like a PIR, if you like. So I've seen some noise around not liking that term, but that's kind of semantics. But the point is, review what happened during the incident, what went well, what didn't. Nobody's at fault, so the words "I'm sorry" are banned. The words "I should have done this" are banned. Accepting the fact that with the best will in the world, everyone did the best that they could with the information that they have, and they did absolutely everything correctly based on the information that they had. Right? That is very hard to do because everyone wants to go, oh yeah, I did this and that was wrong and I shouldn't have done that. Yes, but you believed it was correct at the time, so no, you did the right thing. We learned later it was the wrong thing, but that's not your fault. So that's hard to get right.
Well, I think the learnings is the key thing, isn't it? It should form a part of any post-mortem, post-incident, incident reports that we do for our customers. When there's been an incident, the final section is always the learnings and what we're going to do about implementing those learnings so that should that particular incident occur again, we will be more prepared for it next time around.
And then the article after sort of that talks about things like some best practices, which are best practices not necessarily just for cloud response frameworks, but just in the cloud generally. Things like doing training and write once, read many for logs and evidence, turn CloudTrail on across everything, make sure you can't delete CloudTrail, that kind of thing.
Cool. Okay. Conscious of time, our final article, we've kind of touched on this anyway. So our final article this week was on the Container Journal, and it was entitled Principle of Shared Responsibility in Cloud Native Applications. So we touched briefly on the shared responsibility model in the last article. And in fact, we've covered it in other episodes. But let's just briefly cover it one more time, John, in the time that we've got available. Let's do shared responsibility model in a minute. Go.
All right. So the shared responsibility model applies to basically any kind of lens within the cloud, right? You are responsible for what you do in the cloud. That's your deployments, your permissions, your users, your access, all that kind of thing. The application, pack that one. The provider is responsible for of the cloud, security, availability, whatever. So that's physical, that's data, that's power, that's facilities, that's racking and stacking, that's the OS that runs the virtualization and all that kind of thing. Where this differs when you talk about cloud native and particularly serverless is their responsibility just kind of moves up the stack a little bit, because in like Lambda land, you are only really responsible for your code and for picking the correct runtime. Yeah. Because you say, I'm going to use Python 3.10. Great. They are responsible for everything up to the runtime that gives you access to Python 3.10, and then you have everything above that. Boop.
I didn't set the timer today, but if I had, I think you would have been bang on there, John. Thank you for that. Shared responsibility model in a minute with a serverless slant. Perfect. So that brings us to the end of our time for this week. That was season 2, episode 9 of LogiCast on tour. So we will be back. I'll be back in my shed next week, back in my usual setting for the next episode of LogiCast. Thank you very much for listening, and we will see you again next time.